We're at the point in the curriculum where you may be talking about intermolecular attractive forces. And it might be time for another one of those magic tricks that focuses the student's attention after perhaps they have an idea. So I take a strip of newspaper, and I fold the strip of newspaper, and then with a pair of scissors, cut a section of that newspaper away. But the course holds together. The content is still there. Let's try that again. Take the paper, fold it in half. Now what if we didn't talk about intermolecular attractive forces? Well, that course is still a good course. We still learn something. But we do need to talk about these intermolecular attractive forces because that explains how this happens. Whoa, there the intermolecular attractive forces aren't working really well. Let's try that again. Bring it up, bring it together, use the scissors to make a cut, and there the course is back together again. I wonder what happens. Let's try this. Let's bring it up like this and make a diagonal cut. I wonder what will happen this time. We head off in a new direction with our course. Now, I don't know if we want to do that. We better get back on track, and I better show you how this is done. Over here, I've got one set up because it really is intermolecular attractive forces. I've just taken a strip of newspaper, and on one side of that newspaper, I'll put some rubber cement. I'll cover it liberally because it is the rubber cement that is going to then hold the strips of paper together. As the molecules of the cement come in intimate contact with each other, they will stick to each other through those intermolecular attractive forces. Well, in order to keep them from sticking prematurely, I then have to coat the rubber cement with baby powder. And that puts a layer on the surface so that when the two halves of the paper come together, the baby powder in between keeps the two from sticking to each other. And yet, when I cut it with the scissors, that brings the two into contact with each other, and the rubber cement then holds together. And intermolecular attractive forces really is the key to that magic trick. There are some other intermolecular attractive forces that we do that sometimes look like magic, but really aren't. Many teachers have used the demonstration where you take some water, you put it in a jar, you put the lid, put a plastic or cardboard card over it, turn it like that, and of course the card stays in place. And the students may have seen this. This probably comes early in your curriculum. Of course, it doesn't stay when you take the card away. Now, if this does come earlier in your curriculum, they will be set up for this next thing because you get that same experiment out again. And when you get that experiment out a second time and you fill the jar with water, say, I know that we've seen this before, but I want you to pay closer attention to it this time. This time the water stays in even without the card. Now, how is that happening? The secret is right there. I put a piece of screening over the jar. I hot glued gunned it so it stays right there. And now I can add water right through the screen. And when I show it, I may want to hold my hand up here so it's not immediately visible. And with the card on top, turning it over so they can't see the screen, and then removing. Now, I do always work over the sink. You learn from experience. This truly is working by intermolecular attractive forces. The formation of that surface tension as one molecule of water holding on to another molecule of water and so forth, makes a skin that indeed holds the water in the jar. Intermolecular attractive forces are magical. Thank you.